Shailendra garu, you can start your lecture, sir.
Okay, right. I'm just sharing my presentation.
Yes, sir.
And then is it visible, sir?
Yeah, it is visible, sir. Please
Yeah,
make full screen.
Good morning, one and all. Good morning, Rector sir, Shankar sir, and thanks for giving opportunity to interact with dear friends, student friends. After a long time, again, I am getting an opportunity to talk, to spare some time with our student friends. Being in industry means there is a slight difference, and there is a difference between teaching as well industry. Both are in different entities in our Indian culture, but in future we are going to see it is in coordination with, means actually there are three things which supposed to be work together. It is industry, R&D as well academics. In near future we are going to see this kind of a scenario by changing the academic structure and all. I heard very recent news also. Yeah, thank you for giving elaborated introduction about me, Shankar Garu. Yeah, I'll get into my topic. Good morning, student friends. Okay, I had that around 10 years of teaching experience as a assistant professor and senior assistant professor in various in two different colleges. Majority I spent time in CBIT. Later, I have joined as an engineer, design engineer in Aircraft Research and Design Center. Basically, I am very much interested in research and development. That is the reason I have opted this it's one of the main division in HAL, Aircraft Research and Design Center. Okay, I just right now I'm a manager in design. My topic goes on critical design most because we belongs to a fixed wing development. Okay, I'll tell you about my division. My organization, it is one of the Asian, means it is one of the biggest OEM in Asia, that is Hindustan Aeronautics Limited, which is a corporate and main divisions are located in Bangalore. And next I'll come to my division, especially that is nothing but Aircraft Research and Design Center. Our main duties are design, means it is not starts only from product to, I mean, what is that, raw material to the end product. It is not raw material, we should say from the scratch level. Because for example, some of the people, the raw material is also the end product for some kind of a people. For example, if you take metal ore and all, comes from soil, and they will make billets and give, and those billets will be the end product for them. But whereas billets will be the raw material for the manufacturer peoples. That is the reason I'll combine both of that, and our product, means our things will start from scratch level till the deployment, till the product is made, proven, and deployed into the customer. Even after customer also deployment into the customer location also, there will be a support, design support will be continuously, it will be there. So I cannot say it's only ends there itself, right? It is a kind of a lifetime till the aircraft is available. It means it's not on ground, okay, in air. That way I can say. And proudly I will say, means in our division, what we do is we build the concept, we do the design development in the sense we make the prototypes, and later one more vertical is nothing but testing and proving it for certification, for airworthiness certification, whether it is air worthy to be in air, because it has to be land safely, right? Without, because it links with one after the other, means it is then link, means the product should be fine, means it should not have any kind of a flaw. At the same time, pilot should to be safe, and it is a pride to the company as well, pride to the nation, right? It is linked with the one together only. That is the reason all it will be. That is the reason I'll tell, test air, to be airworthy need to be proven as per the standards. Till once it is proven in all kind of certifications, then the whatever the design which we made will be productionized, means production standard we make it as. Once it is productionized, then it will be given to the other divisions, so that they will do the series production of that particular aircraft. That is the major main activities of our division. Yeah, in this, our department is talking about configuration and mass properties. Yeah, I can say proudly, even though we are not appear directly as a system group or a structure group, being means a secondary level, means not it is the behind screen, but still from the scratch level, even till it's into deployment into the customer, our one on the other form, our work will be there. In one on the other form, our work will be there. That is the major and important role we play in aircraft, maybe in the design, development stage, even in the flight operations stage, right? So that is what I'm a mass properties guy actually. Okay, I'll just get into the my slides. Okay, and last at the end of the session, I'll give you 10 to 15 minutes time for the students for the questionnaire. Okay. Yeah, my main agenda of this presentation is I want to make you aware about the design, what we are seeing, what we are reading in our books, and what we are actually implementing in real time. I just want to map it. That is the main reason I would like to explain little theoretical, not little more theoretical later, because here there won't, I mean, I'm not going to discuss about any kind of equations. I'm just giving a overall glance in our design phases of particular any aircraft. Okay, here I have shared all kind of, except space shuttle, remaining all kind of variety of aircrafts which we make, right? This may be UAVs, okay, and this may be a trainer aircraft and fighter aircraft. So this is a stealth based aircraft, right? Stealth is nothing but which have and help what is that, protective healthy environment. So yeah, being a mechanical student, I just want to
Sir, we don't see your slides changing, sir.
oh mm, now sir.
No, sir. I think you need to show minimize the presentation or share the slideshow.
Okay, now fine sir.
Yes, sir. Now fine, sir.
Yeah, okay,
So,
like
why
this.
don't you? Why don't you just start the show? It will be better, I think. Slideshow.
Okay, slideshow only. I kept it in slideshow, sir. Okay.
Maybe then you need to share that one.
Okay, I have shared it, sir. Just see, sir. Is it fine now?
No, sir. This presentation only we can see. I think you go with the presentation only, sir.
Okay, right. Okay,
Why don't
then.
you share the entire screen, sir, so that it will be easy
Yeah.
for you.
Is it now visible, sir?
No, sir. I think you need to share your screen, sir. Entire screen.
Okay, okay.
Okay.
I do that.
In the Zoom, you have to
Yeah,
share
yeah.
the screen.
No, share screen. Now see, sir.
We still see the presentation only.
No, no, I have not kept it in.
I think you need to minimize this one, sir, first.
Now see, sir.
Yeah, yes, sir. Yes, now it is okay.
Yeah. Right, sir. Now changing the slides.
Yes, sir.
Yeah.
Good.
Thank you. Okay. I just, being a mechanical guys, just want to give an awareness about aircraft, what exactly, just want to make you aware about the terminology, what we use when we are going further into it, right? This is the main body of the aircraft that we generally call it as a fuselage. And based on the length of the aircraft, which we can divide into front fuselage, center fuselage, and rear fuselage, or front fuselage and rear fuselage, based on the length of it. Is the cursor is, showing, sir?
Yes, sir.
Yeah. And these are the main wings, right? And this is the tail boom area, which we call it as a horizontal tail and vertical tail, or otherwise empennage, we call it wing and empennage. And these are the jet engines, and below in this picture we cannot able to see the undercarriage, that is nothing but landing gear. Okay. And whatever the brown color which we are able to see, those we call it as a control surfaces. Control surfaces are nothing but flight control systems, both whatever the rotation, pitch up, pitch down, yak, all these things will be controlled with the help of this. Yeah. So I have given parts of body very clearly, and this is a passenger aircraft, a jet aircraft, and whereas this is a basic trainer aircraft, which is based on the difference between that to this is nothing but only the propeller. Means whenever the means fan based propeller, right? So whenever the propeller is there, automatically engine will be mounted just beside that only, right? Just beside it, just beside to it. And whereas when we are coming to the jets, that depends on the aircraft, each individual aircraft. It depends on the individual aircraft. One to one, it will vary, right? This is what I just want to tell you about the terminology about the aircraft. Now, and as I said, these are the, as per my agenda, these are the things which I'm going to cover in brief. The first one is evolution of aircraft. That is, okay, a feasibility study in design phase. What we are going to generally do in theoretically, you will see design phase. You will see with a simply synthesis, means design, what they call it as a concept building, and next synthesis, and next they will call it as a testing and productionization. But whereas there are a lot of steps which are involved in concept building, that is the kick start of the program. Okay, after that synthesis will happen. Synthesis is nothing but a detailed, means in detail the analysis in the sense, I'll go elaboratively in the further slides. Okay, and next is preliminary design phase and detailed design phase. Then after, once it is made, it will go for ground as well. In-air testings will happen for getting the certifications. Then after, it will go for the productionized, and design will be frozen at that level. Okay. Yeah. Next, yeah, I'm going for the next slide. That is nothing but evolution of an aircraft configuration. Yeah. Whenever any program starts, immediately people will not start working on systems to shape out the aircraft, right? First of all, you should know what you want to make. That is nothing but, you should know what you want to make is nothing but requirements. When you have customer, you don't need to bother about your defining the problem, but still you need to understand the requirements, right? So first of all, what do you mean by requirements? Generally, in our case, we have many of the situations, we have the customers, but all the cases we will not have the customers. Anyone will not have all the time customers. They need to start their own also. That is the second situation. Well, first situation is when the program has the customer, obviously the requirements will be given by the customer. When you do not have any kind of a customer, then what will be the things requirements? You need to start even building the requirements also. That is nothing but it is like a new building, new product development, right? Generally we call it as a product development, new product development. So in these two, in the second case, again you start thinking about, means writing about the requirements. Need to come what kind of requirements you want, right? What type of aircraft you want, and what type of what category, class of category, and what it is supposed to be perform. All such kind of requirements you need to make. This is entire it is a one entire, it is like a new topic. Developing requirements is also a big task. Means you need to approach in different ways, either in doing different kind of surveys, or otherwise you yourself need to do R&D to make the requirements, like going through all what kind of aircrafts are available on globe, and what type of requirements are having the different customers, and is there any gap between among those two, and finding out the gap and how best we can able to meet those gaps. Based on that, is there any contemporary aircrafts are available? If contemporary aircrafts are available, and what, how it is best meeting the gap what we found, right? In that way, it will go in a different direction. It is a separate subject where we can spend a lot of time, right? This is a new product development, right? That is the entire thing. Okay. Okay, this is this stage you will be able to understand from, okay, at this stage you will able to understand, you will get the requirements. The final output from this stage is nothing but only the requirements you will come to know. Once you come to know about the requirements, do we start doing the project, means doing the design, means modeling of the aircraft and all? No. First we need to understand the requirements. This stage we call it as a feasibility study, right? Feasibility study is nothing but whatever the requirements are there, first you need to understand it, whether they are really feasible to meet the, means can we able to really make the aircraft to meet the customer requirements, or to meet the requirements, right? Why, you may ask the question, right? Why it is again required, sir? Anyway we have the requirements, why not we start it, right? Right, this is a wrong kind of a perception. How? Simple example, when we have a desktop example, simple example, a desktop, we will take a desktop as an example. Okay, nowadays we are buying one branded HP or Dell or anything, simply we are booking online and getting it. Desktop, you will get a CPU. But earlier days, how we used to do, we used to go to the different various shops and get the best configuration. What do you mean by best configuration? What is the motherboard? What is the processor, right? And what is the HDD, SDR, DDR? All these things, we, means what is the graphic card? Everything we used to get as a best one. Means in every aspect, means motherboard is the best one, which is the best company and which is the best model, like that. What is the processor? Best model and best company, right? Best processor, like that. We need to take all the things and need to use to integrate all of them and keeping after into cabinet, and we start coding, means we start using the system. And once after writing a code and running your system, then you will come to know, instead of taking in seconds, it is supposed to run in seconds, it is taking in minutes. Then is it really working as you expected? No, because even though individually every part of the computer CPU is maybe the best, but when it is coming into as a team, I'll say it is a team, right? When it is coming in together and working, because those will work together only. One has to transform into other understanding. So among all the equipment, they need to understand and they need to process it and they need to give the result into your screen, right? So this kind of activities, everything will happen inside the CPU and it has to run and give the output in seconds, but it is taking minutes because the lack of integrate means, what is that, interfacing among them. The interfacing is not happening properly. Because of that lack of interfacing among those paths, the output is coming, taking time. It's taking time. So that we should avoid. Avoid means we need to rectify it. How we can able to rectify? If we able to understand, for example, instead of taking processor at Intel 12th generation, 11th generation is enough to work to such kind of a requirement of the end user. So in that way, how we are able to make the decision at some simple computer. Similarly, even here also, you need to understand all the requirements of the customer, whether they are feasible and whether they are means interfacing among them is going to meet the customer's requirements in a proper way or not. And whatever the requirements will be the top line as well, the designer will keep those points as a means, what is that, minimum means it is not the maximum. Up to that level I should not go. I should go, that should be the minimum level for me to work, to perform. In that way, we need to keep into our mind and start working on the requirements, right? In that way, the feasibility study will go on from each individual. Each individual means there are different people. Structure people will be there. Structure people are nothing but, as I said, fuselage and their wing and empennage people. Those are the structural people. And whereas the system level system people are nothing but whatever the belly, aircraft belly has, all those things are nothing but system groups. Like I'll tell you a few of the people, that is environmental control systems, flight control systems, hydraulic systems, right, life support systems, right, seat and safety, electrical and avionics people, right? All these, right, all these people are landing gear system. All these people are system people, right? So system people will also think about in their own line which system, what kind of a system, right? Is it a higher level or a middle level? What kind of a system will be fit into the this whatever the requirements, so that it can able to perform to the level of the given requirement. In that way, each and every aspect, each and every individual will come into their own, means will think in their own views, and they will make the customer to understand, right? Sometimes what happens means, that is why it is required this feasibility study, why we need to spend 2 months or 3 months or 6 months, because we need to take into the whatever the customer, whoever are maybe, right, customer also will be made them to involve, so that right, sometimes what will happen, whatever the requirements may not exactly gives the what is that, the output of the expected requirements, right? So in that cases, you need to make them to understand, and where where we should not say, obviously, for any customer is God. We cannot say no to any customer. We need to make them to understand where to change, how to change. Only means we are not compromising in the requirements, but we are making them to change in the, what is that? It may be a wording or it may be a numbers, scalings, right? May need to mean we are not compromising in the requirements, the final goal of it, but we are changing the which system, what kind of system need to be modified. In that way, we will make the customer to understand and we will make them to understand also, right? It is a two-way communication, right? Once after understanding the requirements. And finally, it has to meet the requirements. There are so many kind of requirements. It may be a, what is that we say, it may be a military aircraft or it may be a civil passenger aircrafts and all. Both has their own standards. As we know how we are speaking UK English, British English. Similarly, even here also we have two varieties of standards, FAR and JR. JR is for UK kind of it, and Federation airworthiness requirements is from US, right? These are for standard, means what is that? Civil aircrafts, FAR, JAR, these, right? And whereas MIL and DEF standards are, MIL standards are military standards, right? Definition of standards, these are UK related, and MIL standards are US based ones, right? One and the other form, both are almost same only, but we have different versions of standards which we need to for whom we are making. If we are making for Indian environment or Indian customers, we need to follow our own geographical conditions based on that. Because simple example, in UK or if you are taking US side, the weather conditions, weather temperatures will vary. But whereas in India, temperatures are in Indian condition, the temperatures are different, right? In that way, one simple example, right? This is what the importance of the feasibility study of any particular requirements, making ourselves and making the customers to understand the requirements, and that will be the thing that will be the means what we say guide. Those will be used as a guidelines for the next project to go ahead, right? This is the first phase, right? Once after the feasibility study is done, we will get into the actual design phase, that is called preliminary design phase, right? From here onwards, actual design phase will start. Means that is nothing but the actual work on to the aircraft will happen from means it will be a kickstart to the program. You can say kickstart to the program. Whatever we had the discussion earlier, everything is now clear. Means we know what we want to, what we have to do it and all, right? All those things are now into our top line, and then we start building the concept. That is conceptual design, right? This conceptual design, right? These are the stages which I have just shown. Design concept through synthesis only. Next is preliminary design and critical design phase. The third one is a detailed design phase, and where exactly we do the modeling with the drawings, right? Along with the drawings. And the last but not the least is the testings. All what we need to do the testings. That is nothing but request for testings. RFTs, we call it request for test, right? What we need to test it and where to test it. Is it on ground or it is on in air, and all kind of things will be defined, and it will be done by different operations people, right? Flight ops people, flight operations. And once it is proven, then actual design will be freezes in that level, right? Yeah, the first step which we are going to do is in conceptual design. What exactly the conceptual design is? Conceptual design is nothing but it is means building an aircraft. is not a one-day job and not a one person's job. It is, as I said, that there are structural people, system group, system people, and not only that, and supporting few groups are also there, like me and other few people are also there. Those together only, it is a teamwork. How five fingers together will happen, I mean, will mingle, then only we will, means we can able to hold and we can able to kick a punch, right? So with one single finger, we cannot do anything. Similarly, here also, it is a teamwork, team building, right? So team only will build the aircraft. So that is the main thing which we need to understand, right? What exactly the concept means, conceptual design. Here, whatever the requirements which we have now, all things will shuffle in, means will rotate in our, means will shuffle in our mind, and we will have our own thought. Whatever the thought process is there, that thought process will come into realistic in means not realistic, in a virtual. That is nothing but in systems we'll start building, means we'll make out the shape of it. Simple, in simple we can say it is the sizing and shaping of the aircraft. Means what could be the outer shape of the aircraft and what could be the size of it, right? When you are thinking about size and shape, you need to understand whatever we know the requirements. Those things need to be kept in our mind. Especially those can be categorized into two things. One is performance characteristics and the other one is operational requirements. What do you mean by performance characteristics? Those are nothing but aerodynamic performance characteristics. That means which includes what could be the range of the aircraft, what is the speed of the aircraft, and at what altitude it is supposed to be, how much time it need to be in air. That is nothing but endurance, which we call it as, and what is the weight of the aircraft and what it is carrying it and for what mission it is working for, right? What means what is the purpose being in air for, right? To be in air, what is the purpose, right? That is nothing but the mission, which we call it, right? So these things need to be simple example. I will tell you only one simple example, one system, so that we can able to address all these points: range, speed, altitude, endurance, payload, everything we can able to address in with one simple example. That is nothing but engine, right? Propulsion system, engine. So what exactly, right? This engine has to give a thrust so that aircraft can have a lift to get into the airborne, right? So once it is airborne, and how much time it is supposed to be there in air, that is endurance. So that means what? How much fuel is required to run the engine, right? That engine should run so many number of hours, and it should not have any kind of a flaw. Means it should not have any kind of a flaw. Not only that, and how much speed it can able to go, right? That is also based on the thrust of the engine, and what could be the range, at what range, what is the height, at what altitude it can able to reach. So means how it is going to give the lift. Lift means again it will have the difference. What is the max, means majority of surface area which we can able to make it, right? So all it means, I'm not including other one example which which able to address all these things. Like this, everyone need to understand and need to give the outputs, so that we can able to design the aircraft. So design the aircraft means before getting into the actual design, we need to finalize what is the shape of the sizing of the aircraft. Means, okay, here we are able to talk about engine. So what type of engine it is going to come, and because this is the major unit which is going to have the more weight in the aircraft. So the payload, what is the weight of the aircraft and what it is going to do. So for doing the mission, what things are supposed to carry, and when it is carrying, what kind of load it is coming on it, and what is the weight of it is going to carry. All such need to be addressed in the category called performance characteristics. Okay, what do you mean by operational characteristics? One already I have linked to it. What is that? Weight, that is nothing but mass and CG. And crew, pilot, what is the pilot weight and who is the pilot? Okay, is it a trainer aircraft, is it a fighter aircraft, right? So based on why I am saying like this, if it is a trainer aircraft, you need to address for 2 pilots, and based on that the cockpits need to be, right? All such means what kind of environment conditions need to be addressed. Means if you are in Indian, as I said, if you are in Indian environment, geographical conditions, the temperatures will go up to 50-60 degrees also, right? So you need to address up to 80 degrees from minus 20 degrees, like that, right? Siachen kind of area, you will have more than minus 30, 40, 50, right? So need to address at a lower, very lowest and the highest temperatures range. Whereas other countries, it will not go that much beyond range. Those ranges they never have, right? So these environment related compliance need to be made for crew and even the internal equipments also, right? Not only just for the crew, means pilot, right? Even the some of the equipments required when it is in air, right? So because we will have plenty of equipments which may give, means which may useful for navigational purpose or communicational purpose, or some of the things for maintaining the maintenance purpose, right? All these things and their associate accessories need to be addressed in this kind of means these are all comes under operational requirements. So we need to understand all these things and make the belly of the aircraft, means the sizing of the outer shape of the aircraft need to be decided, right? So means what are the different LRU, means units are coming, and these units where it is coming, okay, based on its functional requirements, the location need to be decided, and based on the operational means functional means it's functioning of the equipment, whereas operational means sometimes simple example, if you are at means having a 2-wheeler or 4-wheeler, every 2000 kilometers or otherwise every 6 months once you need to go for making make the bike to get serviced. Similarly here also your units need to be checked. It may be for every flight, or it may be periodically, or after every 20 flights or 10 flights, or sometimes some of the things every 3 months, like that, or some not required to check anytime, only at the time of means only at the time of servicing time. So based on the functional requirements, operational requirements or maintenance things need to be addressed, right? All those things need to be kept in mind and start giving the input for making the belly of the means that is sizing of the aircraft. So here, as I said, there are plenty of points which we can able to understand in making the size. First and foremost one is the structure. So based on the type of aircraft, what is right, it may be a trainer aircraft, 2 cockpits supposed to be there, and if it is a fighter aircraft, 1 cockpit. And what type of seating it is it a side by side seating, or is it one behind the other, that is tandem seating, right? Side by side seating means sometimes the cockpit layout will be having a duplicate of monitors or consoles, switches and all, right? Or otherwise, if it is a one behind the other, obviously you should have a duplicate cockpits, right? 2 cockpits you need to build, and right, and what kind of seating arrangement, it may be a bucket seating or otherwise ejection seating, right? So when it is ejection seating, it will have different kind of standards, right? So in that way, one simple cockpit, once you start taking it, where is the location of cockpit? Is it coming in front fuselage? If it is a trainer aircraft, front fuselage and center fuselage also it will share. So that need to be addressed, and what type of a canopy, because right in that cockpit there will be a different types of pilots. Today even the woman is also a pilot, and they are sitting in cockpit and start doing pilot means what is that flight, they are also taking flights. So here you need to address, there is no change in the seat, you will have only one single seat, and you will have only control stick is one single control stick only. But how you will address, you need to address the tallest person as well, shortest person, and at the same time heavy person and thin person, right? All kind of variety of people need to be addressed for one kind of a design stick only, control stick only, and at the same time seating arrangement. It is not a car to adjust your car seat, or otherwise to adjust your steering and all. Here there won't be any adjustments in the steering, means steering in the sense control stick, whereas seat, the other one is a seat, there won't be any adjustments in the seats or otherwise control sticks. You need to address the tallest person, what is the hand, means based on its obviously his hand will be long, as well his leg will be longer, right? Similarly shortest will have a short and weight. All these things, the anthropometry data, based on the anthropometry data which is provided by the concerned departments, need to be taken into the consideration and need to be designed, right? So in that way you need to understand the cockpit requirements. Based on that only the switches, panels, everything need to be placed in the cockpit, and that way based on that what could be the size in the cockpit you are going to get. That is one. The second means, as I said, location. And one more thing, based on the height, the canopy bubble, that is nothing but door, should not hit on their head after keeping their helmet, right? So that should not help it. There should be a clearance. If it is not having the sufficient clearance, it will give uncomfort to the pilot. That everything need to be addressed. There means need to be think, and based on that you need to give the sizing of the belly of the aircraft, that is nothing but fuselage, right? Based on the location, you need to where it is coming, where is the front fuselage, is it coming the completely front fuselage location, or coming a little far after aft side of it, and moving to the center fuselage also, up to what where. Next is you need to develop the lift to raise the aircraft, and what could be the surface area to be have in with the help of wing and emperages only we can able to do it. So the what could be the aerofoil shape, that everything will come into the wing, right? So what type of wing it is it a mid wing or a means is it a mid wing or low wing or otherwise high wing? So based on that, is it a you need to have both main wing as well HT, that is nothing but horizontal type. No, if you don't want to, you want to combine all, that is delta wing. So you need to think about what type of wing it is, type of wing, and what is the location, mid, low or high, right? So all such, and what is the surface area which it is going to give. So based on that, this and where it is locating, right? That all aspects you need to think in a structural concept, right? A structural way. And as I said, engine is the major unit which is going to carry more weight in the aircraft. That engine, and it's obviously it will have its own accessories, right? Where it is mounting, where exactly you are placing it in the aircraft, and there the sizing need to be addressed. And of course, aircraft means it has to land safely. So that landing is very much important. So that is the reason you need to understand where the landing gear is coming, what type of landing gear it is, where it is going to come. And type of landing gear is nothing but nowadays we are seeing tricycle only. Tricycle means one nose landing gear comes in front side, and main landing gear comes in the rear side, right? So what type of landing gear? It is a fixed one, or it is a extended and retracted condition. So both need to be addressed. And what type of landing gear it is, that is nothing but it's a type of, means what type of land it will take. It will be a telescopic one, or otherwise articulated one. So all such things need to be considered for safe landing. And next one is fuel requirements. When you are staying in the air, obviously how much time you are going to stay, how long you are going, all such will be addressed with the help of fuel capacity. So for keeping the fuel capacity, tanks are very much required, where it is located, how much quantity it is carrying. So based on the shape and size of the fuel tanks, also the shape of the aircraft will also need to be addressed. Once the sizing of the aircraft is made, then those things will be made in a what is that, prototypes, not actual prototypes. These are all only scaled prototypes, which will be called as a wind tunnel models. Here I have not mentioned that point, which we will call it as a wind tunnel models. And these wind tunnel models will be made. Of course, this is also will be made in our department. Our people, means we only will make the models. Those wind tunnel models will be given, means it is not in 1:1 ratio. It will be in a scaled one, smaller size, and will be given to the wind tunnel. Of course, it is one of the activity of our division also. We have a wind tunnel where wind will be blown, and aerodynamic performance characteristics will be recorded, and it will be analyzed based on the satisfactory. Again, the change will happen, right? So the sizing will happen, change. There is a change in sizing and shaping. So it is not one-time activity. It is a multiple times. That is nothing but it is an iterative process till we achieve the required satisfactory aerodynamic performance characters. Till we meet to that, this process will go on. Once it is done, the actual, means the outer size and shape of the aircraft will be given to, that is nothing but given to all the design groups. So it will be shared to all the design groups. This is, we call it as the main geometry. Right, for example, simple, these are very olden days. We used to draw like this conventional concept like this. So these, whatever I said now, these are all iterative process. So this kind of iterative means, as I said, this is the wing area, and this is the HT, horizontal tail. So based on the more, means if you have more surface area, you will get more lift possibility. These are the landing gear, and how it is going to, and what is the ground clearance, everything need to be addressed at the time of concept itself. So those will be tested in wind tunnel, and once it is frozen, then the shape of the outer shape of the aircraft will be shared to all the design groups, right? So that part, whatever I have told till now, the conceptual design is the one of the crucial area which will be taken care by our own department. I am also one among that team, right? And I have also involved in one of the project. And now, once after freezing the size and shape of the aircraft, which next we will move to the preliminary design phase. Yeah, sir. Till now we have only spoke about the shape of the aircraft, right? And we know that what are the main means units are coming into it. That till that only we know it. Now everyone will start thinking, whatever the thinking process is there, that will be virtualized and will be placed into the aircraft. That is nothing but layout. which we will make it, right? Means everyone will start doing their own layouts. Individual design groups will come out with their own layout. For example, if you are taking about FCS, flight control systems, what type of control surfaces are there? What is it? A aileron, flaperon, or otherwise of, right, flap, leading edge flap, or otherwise rudder, right? One second. Thank you. Yeah. So what are the control surfaces are going to come, right? And where they are located, and for driving them, means for doing operational of these control surfaces, what could be the circuit, means where the actuators are coming, what type of actuators are coming, and how I need to connect. Is it a fly-by-wire, or otherwise is it a connect, means what is that, rods, means those we call it as a connectors, right? So how it is going to connect? So type of design. Based on the type of design, each individual design group start giving their own layouts with their own architectures, right? Everyone, it may be not only hydraulics, not only flight controls person, he will come, a hydraulic person will come his own architecture. And similarly, other groups also, ECS people, means environmental control people, life support system, all landing gear, everyone will have their own architectures and their own designs, and they will start keeping their own units, equipments, right? And that is also purely based on their own functional as well operational requirements. And based on that, they will start discussing with the individual group, means individual groups along with our people. That is nothing but with our people means configuration and mass properties people. Based on why configuration mass properties people will play a key role in deciding the location of the units, because the CG, center of gravity of the aircraft, need to be maintained in a perfect manner, because there are different category of aircrafts. If it is a passenger aircraft, the CG range will be more, and it is a stable aircraft, because that is the reason you may come across in any flight, the pilot will keep in the autopilot mode, and the pilot also will be roaming here and there along with the passengers. But whereas in fighter aircrafts, it won't be the same. The CG range will be very small, and within that small range, the CG will. Why, you may have a doubt, what is this CG range? Why only 1 point won't be there? A point won't be there in any aircraft, because the first and foremost one, which it is fuel. Fuel will consume once it start into the air. Once it is aircraft is in airborne, obviously fuel will start consuming it. The quantity, the weight of the fuel, once after fuel is consuming it, obviously the weight of the aircraft will change. When the weight is changes, automatically the CG also will change. So that is the reason you may see, if you are very keen in booking the tickets, it may be a new technology tickets, trains or otherwise in aircrafts, they will have, without Maasen CG report, they will not give the ticket properly. Why? Because they will distribute the people, means whatever the ticket booking which happens, they will distribute in a systematic way. Even the cargo also, cargo will be still more precise, right? How we maintain in military aircraft, similarly they also do it. In passenger they may little compromise, but cargo as well, military, without this reports, they will not go for flight, means they will not go for flight. That is the importance of Maasen CG in such in our environment, right? So This is most important thing. So that is the reason in when the layout is deciding where the LRU is coming, that is nothing but what is the weight, size and shape, as well location. These three are very much important when we are defining the siege, not defining, when we are supposed to maintain the siege, right? So that is the reason this layout is most important for any aircraft. It has to meet the functional and operational requirement, because operational requirement maintenance related, whenever you are coming into it, if you want to remove one particular unit, you are not supposed to remove what is that, 5 6 units, and then you need to go for sixth one. It should not be. When you are supposed to access, the accessibility should be proper, and you should be able to access properly, and at the same time it should be okay, and it should be what is that, systematically arranged. All such need to be addressed in the layout design, right? Next one is structural and system groups. As I said, they will come, structural people will come, what type of load, means what type of units are coming, what could be the load of it, and where the load barrier is supposed to be given, and where can be compromised, not compromised, can be given less, like this, where need to be given more, where need to be given less. Based on that, they will make the structural design, and people will give based on their architecture, and what kind of units are coming, and how those units are connecting. Everything will be given in this kind of environment. And once after doing all such, this layout will be, call it as a 2D layout, and which will be given to all the people, and based on that, the envelope will be decided for each individual system, and they have to design in the next further phase within that envelope only, right? They should not go beyond their envelopes. That is the one of the key conclusion in this preliminary design. I'm just skipping about these mass and estimation, successive design, mass balance calculation, and evaluation of mass and CG envelope. I will just skip for for this moment, and later I will come to these points. The next point is, in the same phase itself, in the preliminary PDP stage itself, we also do undertake one more stage called critical design phase. This is like whatever we have made the layout, here still we have a scope of chance, means a scope to change in the sizing of the aircraft, because there may be a chance, means whatever we assumed, whatever we imagined, everything will not go in a same manner. In any, it may not only in aircraft industry, even in our personal life, or even in any industry, it will not go, what we imagine will not happen in the same fashion. So obviously there will be some of the changes, right? Those changes need to be captured at the time of design, because the aircraft is not going to fly for only 5 years or 10 years. It will be, means you need to think about at least 30 to 40 years. It has to have a lifetime of 30 to 40 years. For building is itself, it takes 5 to 10 years of time. And when you are taking 5 to 10 years of time, you should have a scope for future developments also. So in keeping all those things, you need to review each and every aspect of individual structural as well as system level analysis, and need to be finalized at this stage. This is the second and last chance to do any kind of a scaling ups or otherwise scaling downs of size and whatever the units are related things, or weight related things, anything you can able to do it at this level. That is called critical design phase, right? There will be an exhaustive discussions between, means among the groups, right? It may be a structural means whom he is addressing, whom he is serving. All together will sit and how he is going to serve and what the best way we can able to do it. In that way, exhaustive analysis will happen and will be frozen at the end of this phase. Okay. Okay, not only the structural people are system level also. Everyone will have the freezing of their design, right? That is nothing but design architecture, right? Once after this critical design phase, then we will move to the actual design phase. Actual, that is nothing but detailed design phase. Whatever the detailed design phase, once we coming into this phase, now we start developing all the parts in the any modeling softwares. That is nothing but part modeling, and it will goes to the system level and aircraft level assembly levels, right? Assemblies which we make, and all that means not only the parts assemblies and all, even the drawings also. What we are we are in some of the conventional things only, because we are 100% is not moved into the industry 4.0, right? Industry 4.0 talks about digitization. So this there is one concept called MBD, that is model based design. That is nothing but there won't be any drawings, but still we are into the drawing stage only. You need to make drawings also, so that it will be helpful, and it will be not only helpful, it is a guidelines for making the means fabrication of the parts, right? Parts, that is nothing but these drawings need to be made at this level. Means parts will be frozen, what type of part, where it is coming, how it is going to be, all such things will be along with the drawings will be made for further manufacturing purpose, right? Once after the fabrication and undergoing different processes and means method of manufacturing processes, it will be manufactured and it will be goes to the assembly hangars, where the integration of the all these parts to sub-assemblies to assemblies to the system assemblies and aircraft assemblies. So those things will be integrated and make the aircraft to be roll out as a product, right? And here, and once it is rolled out from the assembly integration hangars, then it will goes for various ground testings and in-air testings, so that it can able to move towards getting the certification of the aircraft, right? Once it achieves, or it once after getting the airworthiness certification, then it will goes into the productionized, means whatever the design which is made, that will be productionized, right?
Okay, any students, any questions? Dr. Girish has some questions.
Yeah,
Hello, good morning, sir, and thank you for your nice session.
thank you, sir.
I have one query, sir.
Yeah.
Most of the air in the aircraft actually bypasses, and when the aircraft reaches to the jet stream, whether both the engines switch off.
Can you come again, please?
Sir, when the air comes to the jet stream, it reaches a maximum height. So in that case also, the engine starts, or we can shut it down.
No, it will be in run condition only.
Okay, but I think, sir, maximum air we bypass from the engine to get thrust to the aircraft.
Right.
So to save the fuel, when can we take the advantage of the jet stream or not?
Actually, sir, the engine will run, but as you said, we can make use of it, but we will not do it.
Okay, sir. Sometimes only one engine is running.
Yes.
So
that, sir, that purely depends on the aircraft requirement.
Okay, okay. Thank you, sir.
Okay.
Any other questions? Any other questions? So I think no more questions, sir.
Yeah.
Sir, I thank you, sir, for the excellent lecture and presentation that you gave to us in regarding the critical design of aeroplane. We are looking forward to have more sessions like this from you, sir.
Thank you.
Uh,
Thank you, Shankar sir, and thank you, Vignan College, for giving this opportunity to speak something about industry kind of a work. Thank you very much.
Thank you, sir. We'll end the session now, sir.
Okay.
Thank you, sir.
Thank you. Thank you.